Welcome to one of the most critical lessons in backend development, authentication. This is where we ensure that the people accessing your app are who they say they are, and not some hackers in a basement somewhere. Without proper authentication, you are basically leaving the front door of your applications wide open. Let's make sure that doesn't happen. What is authentication? So what is authentication anyway? Well, it's simply the process of verifying that someone is who they claim to be. It's like when you go to a concert and show your ticket to get in. They check it against their list, and if everything matches, you are good to go. In the digital world, instead of concert tickets, we typically deal with usernames and passwords. But there are other ways too, which we'll get into soon. At a high level, authentication is the first step in securing your backend. Once you know who the user is, you can decide what they are allowed to do. That's where authorization comes in, but more on that later. For now, let's focus on providing the identity of our users. Password hashing and storage. Alright, let's talk about passwords for a second. You know how every app asks you for a password? Well, it's not enough to just store passwords as they are. That would be a security disaster waiting to happen. Imagine if someone hacked into your database and all the passwords were sitting there in plain text. Game over. Instead, we use password hashing. Hashing is a process where we convert a password into a scrambled mess of characters. This scrambled version is called the hash, and it's what gets stored in the database, not the actual password. When a user logs in, we hash the password they provide and compare it with the stored hash. If they match, boom, you are in. Two popular algorithms for this are bcrypt and script. These are hashing algorithms that are specifically designed to be slow and computationally expensive, which makes them harder to crack. Because, hackers love speed. Here is a quick breakdown. bcrypt. It's been around for a while and is super reliable. It hashes passwords in a way that is resistant to brute force attacks. Plus, it automatically adds something called the solve, a random string added to the password before hashing, to make sure that even if two users have the same password, their hashes will look different. Script. This one is similar to bcrypt, but even more resource intensive. It's designed to use a lot of memory, which makes it even harder for attackers to crack passwords using specialized hardware like GPUs. So yes, hashing equals security. Always hash your passwords, store the hash, not the password. Token-based authentication, JWT and Auth 2. Now let's step it up with token-based authentication. This is where we don't just deal with usernames and passwords every time a user interacts with the app. Instead, we use tokens. Imagine you walk into a club. Instead of showing your ID every time you want to move between rooms, you get a wristband when you first check in. That wristband proves you've been authenticated. So you just flash it whenever you want to access different parts of the club. In the digital world, this wristband is a token. The most popular token format these days is JWT or JSON Web Tokens. Here is how it works. The user logs in with their credentials. If they are authenticated successfully, the server generates a JWT. This JWT is sent back to the user and is stored, usually in local storage or a cookie. Every time the user makes a request, they send this JWT along to prove that they are authenticated. The server checks the JWT, and if it's valid, it processes the request. The cool thing about JWTs is that they are stateless. Once a JWT is issued, the server doesn't need to keep track of it. The token itself contains all the information needed to authenticate the user. like their user ID, roles, and any other relevant data. Plus, they are signed using a secret key, which means that they can't be tampered with, or at least not easily. On the other hand, you might also hear about OAuth 2. This is more commonly used for authenticating users via third-party services, like when you log in into a website using your Google or Facebook account. Instead of handling passwords yourself, you outsource the authentication to a trusted provider, and they give you an access token to use. We won't dive too deep into OAuth 2 here, but it's worth knowing that it's a go-to standard for handling third-party logins. Session management. Another approach to authentication is session-based authentication. This is the OG method, original method, or old generation method, where after a user logs in, the server creates a session, which is a unique ID tied to that user, and stores it. The session ID is sent to the user in the form of a cookie. Every time the user makes a request, this cookie is sent back to the server, and the server checks the session store to see if the session is still valid. If you've ever logged in into a website and stayed logged in as you browse, that's likely session-based authentication. However, unlike JWTs, sessions are stateful, meaning the server has to keep track of each session, and you can run into scalability issues if you have tons of users. In modern apps, JWT-based authentication is often preferred because it scales well with stateless servers, which is important when dealing with microservices or distributed systems. And that's a wrap for authentication basics. You've learned the importance of securely hashing and storing passwords, what token-based authentication is all about, and how JWTs helps you build stateless, scalable systems. You also got a peek into session management and the popular OAuth 2 protocol. Now that you know how to make sure users are who they say they are, you are ready to dive deeper into authorization and security. Let's keep this momentum going. Access and authorization. Authorization techniques. Alright, now that you've got the basics of authentication down, making sure users are who they say they are, let's take things up a notch. It's time to talk about authorization. While authentication is like letting someone through the front door, authorization is all about what they are allowed to do once they are inside. Are they just browsing, or they get full VIP access? Let's dive in. What is authorization? In simple terms, authorization is the process of defining and enforcing what actions a user can take once they've been authenticated. Just because someone can log in doesn't mean they can do whatever they want. For example, think of a shopping app. Customers can browse products, add items to their cart, and make purchases. Admins can add, edit, or delete products and see all customer orders. Support staff might only have access to view customer orders and offer help. These different sets of permissions are what we are going to manage with authorization. Rule-based access control, or RBAC. First up, we've got role-based access control, or RBAC for short. RBAC is like assigning everyone a specific role, admin or editor or user, and then based on that role, you define what actions they are allowed to perform. This is one of the most common ways to handle authorization because it's simple and super effective. Here is how it works. Define roles. You first decide what roles your app needs. For example, you might have admins, manager, user, or guest roles. Next, you assign permissions to each role. Maybe an admin can perform all actions, create, read, update, delete, while a regular user can only read and update their own data. Assign roles to users. Finally, each user is assigned one or more of these roles. This determines what they can do within your app. Example in action. Let's say we've got an app for managing articles. Admin can create, read, update, and delete any article. Editor can create and edit their own articles, but not delete them. Reader can only read articles. With RBAC, it's as simple as checking the user's role before allowing access to specific action. Attribute-based access control, ABAC. Now, if you want to level up your authorization system and get more granular, you can use attribute-based access control, or ABAC. While RBAC is role-based and fairly straightforward, ABAC is more flexible. It lets you control access based on attributes of the user, the resource, or even the environment. Here is what that means. User attributes. These are things like the user's department, location, or job title. Resource attributes. These describe the resource a user is trying to access, such as type of file, the file's owner, or its sensitivity level. Environmental attributes. This could be factors like the time of the day, the user's IP address, or the device being used. ABAC lets you define super specific rules based on these attributes. For example, you could allow users to access certain data only if they are in a particular location or accessing it during business hours. Example in action. Let's say you have a document management system and you want managers to edit documents they have created, a human resource to view all employee documents, but not edit them unless they are flagged as pending. Remote employees to only access certain sensitive documents when connected to a secure company VPN. With ABAC, you can create rules like if the user is a manager and the document is created by them, allow edit. If the user is the human resource department and the document is flagged as pending, allow edit. If the user is remote, deny access unless connected via VPN. It's all about giving you finer control, but as you can imagine, this can get pretty complex. It's more powerful than RBAC, but also requires more planning and configuration. Excited about diving deeper into the world of software architecture? This video is just the beginning. Check out my Udemy video course on software architecture, where I explore these concepts further and dive into real-world challenges. The link to the course is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free access to all my courses. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more updates and tech insights. See you next time.